All right, so many of our acyl substitution reactions can be done in multiple ways. They can usually be done under acidic or basic conditions, like either one will work. But we have to be careful of what the conditions are, and whatever the conditions are, we have to make sure that our mechanism makes sense. So for example, if you had an ester and you added hydroxide to it, you would end up with a carboxylic acid. If you had an ester and you added some acidic water, right, H3O plus, you would end up with a carboxylic acid. So the end result is the same, but our mechanism is different. And we have to make sure that our mechanism makes sense. In general, in basic conditions, we're going to have negative charges. In acidic conditions, we're going to have positive charges. So in this basic conditions, we've got a strong nucleophile, right? We've got that negative charge, so that nucleophile has no problem attacking this electrophile. And then we have an O minus, our tetrahedral intermediate. And then this O minus is just going to take its lone pair, kick this down, and then kick off our Y group. In this case, it would be an alkoxide. This alkoxide would then deprotonate this carboxylic acid, and you would have to do some kind of aqueous workup to end up with a neutral carboxylic acid. But overall, you can see in our basic mechanism, we have negative charges, and that's okay. When we take a look at our positive or acidic conditions, we want to only have positive charges. And in this case, our nucleophile is going to be just neutral water. But neutral water is not a good nucleophile, so it can't just attack any old electrophile like the hydroxide can. So instead of making our nucleophile more nucleophilic, we can make our electrophile more electrophilic. And the way we can do that is by protonating our carbonyl here. Put that positive charge right there. And now we can have water come in and act as a nucleophile. Even though it's a weak nucleophile, we've got a really strong electrophile, so that part of the equation balances out. And then after that, we want to do some proton transfers because we don't want to have any leaving group leaving with a negative charge. We want to avoid negative charges. And our leaving group is going to be this O-methyl, but first we need to protonate it. So we're just going to do a couple of proton transfer steps. We're not going to draw them out because that's just tedious. But overall, we'll have some neutral OHs, and then we're going to protonate our O-methyl. And then all we do is reform our carbonyl. So we're going to have take a lone pair from either one of these alcohols, kick them down to form a carbonyl, and then kick off our, in this case, methanol group. In this case, that oxygen is still protonated, so then we just need to do one more proton transfer step to get it to be a neutral carboxylic acid. So notice in the acidic conditions that we mostly have positive charges. We don't see negative charges anywhere. Of course, this wouldn't be a chemistry class without exceptions. Amines are an exception. So for example, if you have an amine attacking our carbonyl, you'll end up at some point with an O minus and then an NR 3 plus. That's okay. And then the other one are going to be neutral conditions. Some of our derivatives are reactive enough that they don't need a strong nucleophile or a acid catalyst to do their work. And what we're talking about here are acid chlorides. They're the most reactive ones. And so what we have here is just neutral water coming in, doing our attack. And what you'll notice here is that on this next step, we have both a positive and a negative charge. That's okay because we're in neutral conditions. We're not on the extremes of either end. And then this one just kicks back down and then kicks off our chlorine. then we do one more proton transfer to deprotonate that OH2 into an OH, and we end up with a carboxylic acid. So when you're not at the extreme at the end, using a nitrogen nucleophile or using an acid chloride, you can have both positive and negative charges. But when you're under acidic or basic conditions, you want to think about what charges and what compounds would logically exist under said conditions.